So hello all, I welcome you to this another video lecture in the series of computer system architecture, and today I am going to explain you half subtractor in the detail, where I will explain the truth table of half subtractor and how to design a circuit uh, for the half subtractor, and also we will see that the output of the half subtractor, and to simplify the output in terms of boolean functions in form of x and y, which are the two input variables for this half subtractor. So what is a half subtractor? Is a combination circuit for subtracting two binary numbers. Okay, so I have written subtract 2 bits means two binary digits, two binary numbers. It has two inputs x and y. I have taken x and y, and two outputs which are borrow and difference. Borrow, that you borrowed, like in decimal numbers, when you subtract from one number to another number. Sometimes you borrow because the number is the upper number, or the subtrahend is less than the sub in which we are going to subtract. So in that case we borrow 10 in terms in decimal, but here in this in the binary we borrow in the same way like in decimal numbers. So let's start with the definitions of half subtractor. It's used to subtract two binary numbers. So I have written xy, so you will read it as x minus y, x minus y, or simply you can look this like x, y, and minus here. So this is same as x minus y, right? So let's take these inputs, right, in the form of two binary numbers, and two binary numbers are nothing but the combination of these 0 and 1, which is 0 0 0 1 1 0 and 1 1, like that we have already done it in half adders, right? So in the case of 0 0, so nothing, the difference will be 0, and we don't need to borrow any number, so we will put 0 here. And in that case, where x is 0 and y is 1, so 0 minus 1, in 0 minus 1 we have the difference. So what is the difference in that case? Can you the difference in that case is 1, because if we are going to subtract 0 minus 1, it will be minus 1 in the decimal. So in the binary number system it will be 1, and in that case we have to take some borrow. Right? So we will write 1 here. Right? So this can be quite confusing, because let's take this understand this point here, that the x is 0 and y is 1. So in that case, what will be there? The 1 will be there as a difference, but the borrow that I have written is 1. Why I have written is borrow is 1? Because suppose if there is a case that there are some numbers here, right, like 1. So in that case we have to take the borrow. So for that scenario, when we have more than 1 digits for the subtraction part, so that's why I have written b here, because in that case when this is 0, x is 0 and y is 1, so we have to take the borrow. So that's why I have written 1. Okay, let's take this case. X is 1 and 1 is 0. So 1 minus 0 will be 1. Difference is 1, and we don't need to take the borrow from in this case. And for 1 1 we have simply 1 minus 1 is 0. Difference is 0, and borrow is again 0. Right? Okay. Now we have to draw a Karnaugh map for borrow and difference. Okay, so let's quickly draw a Karnaugh map for these two, for borrow and the difference, right? So for borrow we have and again, to remind you that in Karnaugh map it's just a rectangular square box in which we have to place the ones, because we are going to evaluate the sum of product form of x and y. So we will write x here and y here. So how many number of cells will be there in this Karnaugh map for B, right? This is for B stand for borrow. So because we have the four possibilities, so we have the four cells here. Again, for the formula 2 raised to power n, where n is the number of input variables, so n is 2 here, so that means we have 2 raised to power 2, which will be 4. So we have the four possibilities. So that's why I have written I'm using this as a 4-cell Karnaugh map. So we will write x0 because there are two possibilities for x, 0 and 1, and for the y we have the two possibilities again for 0 and 1. So how to place 1 here in these cells? As you can see here, we have 1 here only in that case. So for when x is 0 and y is 1, we will place 1. So when x is 0 and y is 1, we will place 1 here, right? So we have this one here, and all other cells are 0, as you can see here in this table, right? So we can directly write that for borrow we have this borrow equal to, it will be x complement and y, because x is 0 and y is 1, so we will write x complement and y here, right? And for C, which is for D, which is your difference, so we have again this Karnaugh map. We have to draw this Karnaugh map for the which has the four possibilities. So we have 4 cells because 2 raised to power 2 which is 4, and n is the number of input variables. So likewise we will draw this Karnaugh map for the two variables x and y, and for x we have two possibilities, 0 and 1, and for the y we have two possibilities again, 0 and 1, right? Okay, now here we have two ones because it gives output 1 for these combinations of x and y when x is 0 and y is 1. So when x is 0 and y is 1 in this cell, we have to place 1. And for x is 1 and y is 0, we have this one. Okay. So x is 1 and y is 0. So x is 1 and y is 0 in this cell. So for this, we will write the function as d equal to x complement and y for this cell, because x is 0 and y is 1 again. So we will write x complement y plus, now for this one we will write x is 1 and y is 0. So x is x, okay, because x is 1, because okay, and y is 0, so we will write y complement. And again, if you remember from the logic gate truth table, this is the table and this is the truth table, or this is the boolean function for the XOR gate. So we will write directly x XOR y, x XOR y, right? Now, so draw a logic circuit, right? draw a logic circuit for this half subtractor is very simple to draw a logic circuit for the half adder, because in exam they are going to ask you that draw a logic circuit for the half adder. So to draw a logic circuit we have to consider 3 steps, and we have to do these 3 steps before we come out to draw a logic circuit. So first step is your truth table. Second step is your to simplify the boolean function used with the help of Karnaugh map. And if you don't know that what is Karnaugh map and how to write these functions and how to simplify the boolean functions, right? So you can watch my other videos that because I have already started this series, and this is 9th video lecture in the series of computer system architecture. So because we have 2 variables, so we will write x and y here, and then let's implement this function using the logic gates. So which gate we have to use to design a circuit for this function x complement y. So for x, so to become x complement we will use the NOT gate or the inverter, right, which is this decision NOT gate. It negates the input. So if the input is 0, it will be 1 here. If the input is 1, then it will negate it to 0. So the input is x, so it will be x complement here, right? X complement, and then y is simply here, right? So just use this y, right? And they are fed into this AND gate, because you know the x complement to y is like dot product between these two, right? So the x complement and y. So we will use the AND gate for B, which is Poro, and for this one we are going to simply write this x XOR y. So we will use the XOR gate for this operation, for the difference operation, right? Okay. Now this is your difference operation, and here we will x will be fed into this and y will be fed into this, right? So it will be your x or y, right? So here we have x complement, here we have y, so it will be valid to x complement dot y, and for this difference we have x or y, because x is here and y is here. So we have x XOR y. Okay. So this is your first step to draw a logic circuit for this half adder. So first you have to do what you have to do. You have to write a truth table for the half subtractor, and then in the second step you have to simplify these outputs by placing it into the Karnaugh map, and then in the third step, which is your logic circuit. So this is your logic circuit, right? So this is a 3-step. These are the 3 steps, and by following these steps you can simply draw a logic circuit for any combination circuit, whether it's half adder, full adder, subtractor. Okay. So thank you very much, and For any query, you can drop a message in the message box. So thank you for watching.